Hello, this is part 2 of a Constraint Actor tutorial for the May 2011 release of UDK. My name is Barrett Hudson, and I'm a student at the Guildhall in cohort 16. Today is June 4th, 2011. When we left off in section 1, we had created this gate here with this Constraint Actor we see, and basically we were able to push our gate open and push it closed, but that was about all it did. And so now I want to go ahead and show you how to add a spring to this gate so that once we open our gate, it will try to swing back closed, and it'll kind of stay in the closed position unless you're pushing it, actively holding it open. So first thing we'll do is we'll select our Constraint Actor, and we will press F4 to bring up its Properties menu. And once again, we'll expand out the RB Constraint Actor tab. And then we'll go down here to the Constraint Instance tab, expand that out. And then we will expand the angular, since we're dealing with angular constraints with this pivot. And what we want to do is we want to go ahead and check this swing position drive box. And what that essentially does is it takes the current position of our gate and sets that as its default position, and it's going to apply a force to that gate to try to put it in that position anytime it's out of position. And so to see how that looks, we can go ahead and close our Properties menu and right click and say play from here. And if we push our gate open, you can see it kind of swings back closed and slowly will settle back into place there where it was initially. So we can grab it and pull it open, but when we let it go, it swings back closed. And so that's what an RB position, or the position drive does on an RB Constraint Actor. If we exit out, we can go back in, and you can see that if we open up the linear side, there's also linear position drives. We won't use those today, but just so that you know they're there. There's also what are known as velocity drives, and what velocity drives do is you can come down here to the angular velocity target and set it to a set velocity in the X, Y, and Z direction, and it will try to maintain that velocity. So anytime the actor is not traveling at that velocity, it will apply forces in those directions to try to make it travel at that velocity. So we won't play with that today, just want to let you know that it's there and that that's what the velocity drives do. What we do want to do is, when we played with our gate in game, I noticed it was swinging back and forth a whole lot, and didn't seem very realistic for a metal gate. And so to adjust that, we can play with our angular drive spring and our angular drive damping. And basically the angular drive spring is telling it how much force it will apply to sort of push that gate back into position. So if we go ahead and reduce that down to 25, that'll make it not snap back quite so fast. The angular drive damping property essentially tells it how much force is absorbed by the angular drive anytime it passes its center point. And so that'll help it slow down more quickly when it gets to its center point. And so we'll go ahead and set that to a relatively low value, something like 5. Just so that you know what it is, this angular drive force limit applies if you have a velocity target, and that tells it what the maximum amount of force it can apply to to an actor is to try to get it to its target velocity. And just to show you, if you expand the linear, you'll see that it has similar properties with the linear drive spring, the damping, and the linear drive force, in case you're dealing more with linear constraints and linear drives. So now that we've got that set up, we can close our Properties window and right click and test our map again. And we'll see it swings back much more slowly and will stop much more quickly now with our new setup. So it looks a little bit better, I think. And we could continue to play with those numbers till we get just the effect we're looking for, but I'm happy with it where it is. And that concludes our more advanced setup for our constraint actors. And thank you for watching this tutorial.